As David says, I am recently retired from Chichester, and an awful lot of what I'm going to draw on is based on my experiences at Chichester. So it is a very personal perspective on the evolution and impact of statistical analysis in sports science. So there's a picture of me pushing on my parameters at the sides there. That's what I was trying to do. When I was employed by the sports department at Chichester, I initially was one of very few. It was one of very few universities that actually had a statistician as part of the sports team, somebody who had qualified with statistics as part of their degree, as opposed to what normally happened and still does predominantly, which is where sports science departments have various people with an interest in statistics, or they have been coerced into having an interest in statistics, being the person who leads on the statistical aspects of sports science analysis. So that was the position that I was coming from. When I joined the department back around 1998 in Chichester, sports science was quite different from what it is now. What was on offer then was literally an undergraduate and a postgraduate sport and exercise science degree. I was employed because they needed someone suitably qualified to teach the statistics and research methods part of a master's course, which did split the course into sport and exercise psychology, sports psychology, sports physiology, and sports biomechanics. And actually the word exercise didn't come into the title. I probably shouldn't have put it in at the 1998 level. It didn't come into the title until the widening impact of the health and exercise side of both governmental and societal concerns as we moved into the 2000s. Up until then, it was sport. Sports science started in UK universities in the 1970s-ish, although we all know that sports performance excellence have preoccupied people probably since the Greeks. And it started around it's the early 1980s in Chichester. So when I joined, it was fairly well established in Chichester, but was still sort of growing within the sector. And so it was very much focused on those three disciplines. I did a quick search yesterday of what's on offer at Chichester for a 2025 start. That's how many different programs there are now. And for me, the key difference is that now that sort of umbrella psychology, physiology, biomechanics has turned into much more focused, sort of almost niche topics. But by virtue of doing that, it has actually targeted the methods and the statistical analyses a little bit better. Everybody isn't trying to do everything. People are becoming much more expert and much more aware, but in sort of smaller bounded areas, which I think has made things better moving forward. But where I want to start from is the 1998 position, and I'm going to get us to the sort of around now by the end, and also the implications of how what we do in sport has informed some of the things that we're doing elsewhere now as well. So the sort of impact of the sports analyses. Back in the 1980s and the 90s, the challenge for sport was that it was seen as a soft science. It wanted to be taken seriously, but it was seen as the public view was that it was playing sport, doing games, taking part in teams, joining leagues. And that was the case for some of the students at Chichester as well. So it was we were very aware as a department that we were in a sector of higher education that had to fight to be recognised as a science. And the reality that within the university settings, the higher education settings, sports science was gaining experience of lab testing. There was considerable amount of physics included in the biomechanics parts of the work. There was a lot of biology in the physiology parts, as well as the need to study the psychology. And the public view, the external view of what sports science was not the sort of riding a bicycle to exhaustion while attached to a mask that was collecting your gases, and possibly, and it always sounded rather uncomfortable to me, a core temperature probe stuck up areas that perhaps we don't want to think about if you're sitting on a saddle. So there was a lot of discomfort. There was a lot of need for high motivation to collect these data, and I think it was something that went entirely. It passed an awful lot of people by. That the sort of the focus of the work was, from an external perspective, was on the sport aspect, and what internally we were trying to do was, within the sports science discipline, was to try and get the science part recognised. So the challenge at that point was not only on the sports side of it, but also on the statistical methods side of it. And part of that was literally engagement, the motivation of not just students, but some of the sports scientists to be aware of the analysis, the need for analysis and ways to analyze the data. And also, other challenges were the limited experiences of those involved in the early days. They had come, a lot of them had experience of science or had experience of sport studies, but not how those two things link together, and not how the challenges, the different constraints on the sports setting might impact analysis. And there was also this desire to be known as a serious science. And I can remember several conversations with people saying, when I suggested that perhaps they didn't use a t-test with 4 people, and that they produced different kinds of, maybe some descriptive statistics, perhaps, or maybe some graphs or charts that showed how things had changes. And the message was, well, if we don't use proper statistics, we won't get published. And by proper statistics, they meant t-tests, ANOVAs, correlations, regressions. That's what statistics meant to them. A very, very small part of what statistics will mean to an awful lot of you. But for them, that was the experience they had, and it had to be those proper things. It couldn't be a bar chart, a histogram. It couldn't even be non-parametric testing. It had to be these proper statistics, as far as they were concerned. And it was true that, because we tried with a couple of studies, I persuaded them to take a different route. And the reviewers were asking where the results were. Why hadn't we got a p-value? Why hadn't we got a t-statistic? Why? So there was a sort of a pushback against the sports science journals wanted to be seen as scientific in the way that some of the medical journals were, and therefore they were looking for that kind of content, even though historically we know that an awful lot of journals that were published around that time, journal papers and articles, had faults in the statistics anyway, regardless of whether it was medical or any other kind of science, or not even a science at all. One of the things that I think was a positive, I found this paper from the year, it's a paper that I've used several times, from the year that I started, or around the year that I started at Chichester, that just shows that actually at that stage people were beginning to think these authors should be congratulated. I'm not holding them up as something that shouldn't be congratulated for. I think they should. they have acknowledged, if you look at the bottom of the data analysis, they've acknowledged that the difference tests were deemed inappropriate because of the difficulty of satisfying confidence in a small sample that they'd met the assumptions of those tests. However, there was definitely developing awareness of the constraints and the things that were problems. But they did do a Pearson product moment correlation analysis with a sample of 12. And so, and while acknowledging that the interpretation should be qualified due to the small sample size. Now, I think that's a positive. It's things moving forward, because up until this point, a lot of statistics were used without that sort of expression of caution. And so it's showing you how some of the thinking is beginning to move on a little bit, I hope. So where did I find myself when I started was, first off, challenging the norms, the things that people had always done. Challenging the small sample sizes, particularly small sample sizes from specialist populations. I can remember a lot of discussions around, yes, but if we're only testing Olympic swimmers, if we've got a sample of 15, isn't that lots, because it's a large amount of the population? And a conversation that I had with a colleague who left sports science to move into some research work with the military, who had managed to get almost a whole population of a particular, very specific group of people. But it was still a very small sample. What do we do with these things? And also, what do we do with samples that become specialised unintentionally, maybe because the people who will volunteer to do the quite labour-intensive studies are a particular kind of person. So you end up with quite a selective group of people who are very happy to do some of particularly the physiological testing within sports science labs, that then can bias your population, your sample, and therefore your population in ways that you didn't intend. Things like it's often the very fit rugby and football playing men who volunteer to do some of the studies. And so therefore it's hard to get those sorts of studies with different populations, or if you like, a wider population. Other challenges are that you've got specialist audiences. Sometimes I was trying to explain to people things that their experiences didn't enable them to understand. So, for example, I can remember challenging a colleague in psychology about calculating means and standard deviations and doing a regression, treating 5 groups as a continuous variable. And could we not turn that into a factor variable within the analysis? And I was told, but we always do it this way in sports psychology. And I tried to explain it mathematically with symbols and stuff, and I was told, oh no, I don't understand. I don't want to know anything about that. I just need you to do it. And my question was my statement was, but if we keep doing what we always do, we won't make progress. And from that point, we had that I had to sort of hunt around and find people who, if you like, build a band from inside in Chichester. And I sense that the same thing was going on in other universities from my discussions around people working within the sports science settings, most of which was done within universities at that point. Now, with increasing money in some parts of the sports community, there's quite a lot of sports research and sports analysis that goes on, science-based research that goes on within clubs, within teams. And it's not necessarily all university based, but it was then. So early advances, things started to change. One of the things that started to change was that we got, was that there were collaborations between people with both sport and mathematical backgrounds, and statistical backgrounds, who started to question whether actually what we were measuring was the right sorts of things and whether they were reliable enough for us to do further statistics on. And also, I mean, if you look at the date on this paper, this is 2000. This was published in 2001, and it didn't use the t-tests and ANOVAs that had been preoccupying everybody. This particular paper used non-parametric approaches and was quite readily accepted. And from that point onwards, what started to happen was that people that were doing the research stopped thinking in terms of I've got a pre and a post test, therefore I've got two groups, therefore I've got to do a two-group difference test, and started to think about the question that they wanted to answer. And yes, you might have a pre and post set of data, pre-training, post-training, pre-supplementation, post-supplementation, maybe pre-training, post-training, and a retention test. But what do you want to do with those data? What do you want to know from them? It isn't, oh, I've got three groups, so I must use an ANOVA. But starting to make the statistics work for the research problem rather than making the research problem fit the statistics that they knew. So there were big advances. There have been big advances in sports science since the mid 2000s, but still t-tests and ANOVAs are used a lot. I mean, here's an example of something that still concerns me that you see in publications. You may find that within one study, you'll have means and standard deviations, normality checks using a Shapiro-Wilk test, intra-class correlations, paired t-tests on some variables, two-way within groups ANOVA on other variables, effect sizes reported, which is great because you didn't used to get that very much. And there's a lot of good in this. I extracted this from one particular study. And the positives from that study for me were you could see where all of these things had been done. There was clear linkage between the methods, the statistics, and the results that were reported. There's an awareness that you don't just report a significant difference, p greater than 0.05 or p less than 0.05 being the bit that you see, and you saw no other values at all, which was the case within sports research certainly in the 90s. You now actually get, you get the results of the tests that have been completed. However, in this particular paper that I took this from was published a couple of years ago, with a sample size of 12. And all of these happened with the data from those 12 individuals. And it's so that, which sort of suggests to me that there is some lack of consideration of some limitations still. Meanwhile, there is less reliability on those kinds of statistics, and we now have a wider use of more statistical methods and greater awareness of options and limitations. So there are a lot of papers that don't include as many tests and as many uses of the same data as were shown in that previous example. And in particular, because we now have a variety of disciplines under that sports science umbrella, as I showed you in one of the initial early slides, The variety of disciplines gives focus to the analysis, such that, for example, performance analysis, which is a branch of sports science in itself now, and an awful lot of football clubs, rugby clubs, hockey, netball, employ performance analysts to collect data about the sort of sequence of events, for example, that cause a successful penalty, or in football, or the sequence of events that cause a successful try during a rugby match. And a lot of data are collected. Quite a lot of it is categorical, because they'll collect the segment of a pitch or field, the position, the number of shots, the number of sort of set up shots that have been have preceded what they're interested in. So quite a lot of the data is categorical, but they also, as you'll have seen from matches and things on the television, they also include GPS systems. Players wear GPS systems, so you can track how far they've travelled, and they wear heart rate monitors, sometimes during matches, sometimes during training, and sometimes both, so you compare the two. As a result of that, there's a lot of logistic and log linear modelling that goes on in performance analysis, quite technical analyses, sometimes with some component reduction of multiple variables before the models are completed, in order to model and the optimal performance parameters, so that to inform coaching and player training. One of the challenges then is that sometimes the performance analyst has collected and analysed data in a fairly complex form, but it needs to be put into an evidential format that means that the coaches and the trainers are convinced by what they see, because they understand the bit that is given to them in a way that then they can translate that to the players. So the communication chain there goes across sort of several different levels of need of need. The performance analyst is working at the sort of statistical level. The coach wants to know the sequences, and the player wants to know what to do. And all of that sort of translatory communication can be challenging. Certainly the performance and analysts that I have come into contact with have some of the things that they struggle with sometimes is knowing what they know and then helping other people to know what they know in the right format, which I think is what we all have to do when we're trying to communicate statistics within our societal settings. But that's the sort of particular performance analysis area. Within psychophysiology, we've done quite a lot of meta-analyses. There have been quite a lot, some of which I've been involved with from the Chichester perspective, where a lot of studies have been carried out, perhaps using different forms of cognitive manipulation, maybe fatigue, perhaps supplementations, and they're done with small samples, and lots of them have been done over many years. And it is recognised that the samples are very small, maybe 8, maybe 10, maybe 12 people. But a lot of them are very, very similar. Initially, there was a lot of sort of reinventing of the wheel around the physiology and the psychology areas within sport. Lots of places were doing the same thing, both within the UK and outside. But one of the problems that we have had with those is that in the published studies, as I said a while ago, poor reporting of findings just literally in relation to a threshold level of p equals 0.05. Is it above or is it below? Is it significant or isn't it significant? Has meant that sometimes it can be really disheartening. And the meta-analyses that start off looking promising, maybe you locate 80, 90 papers, of which 30 have similar methods and would be combinable. But maybe, I mean, sometimes we've reduced that down to, I think the smallest was about 10 out of starting from near enough 100 that had sufficient detail in them for you to be able to use them, or whereby we could contact the authors and get the background information that we wanted. So it's developing. As you saw from my example a while ago, the effect sizes are now reported fairly readily within sports science, which is great. It helps with it helps with taking those studies further towards meta-analysis, but it also helps with translating significant or non-significant results in the light of the sample sizes and the types of populations that we've had. So it is tightening up. The statistical methods are tightening up considerably, both in terms of what we're seeing. There's also been an emergence of use of some much more complex methods for sports science, things that they hadn't used as much before. The use of multi-level models, use of confirming structures of psychological questionnaires before they take them further into what they want to do. So very much becoming more aware of the kinds of limitations and problems that you may have with data before you start to look at what that might tell you. So although I would say that there's still a lot of use of correlations and regressions probably as the main forms of analysis, along with difference tests, sport has become much more open to lots of different methods, and the sports science community are much more open to exploring different kinds of methods as well. So the trajectory of sports science has become much more influential, and particularly the use of knowledge gained from sports science to inform other forms of sort of exercise and health around other areas just that are sort of allied to physical activity rather than just sport. So my next couple of slides show you some of the ways that Chichester has been able to build from its sports science background and branch into other areas. And these are just examples from Chichester, but I know that there are similar examples elsewhere across the country working within sports sciences. I can only, as I say, call on my own experiences. One of them is an occupational performance research group that works with the emergency services, armed forces, and similar organisations to investigate the impact of training on young soldiers, for example. One study that it's not on this slide, but it's a study that I think is quite interesting, was around the fact that quite a lot of recruits in early training experience bone fractures, and we undertook a study to see whether the time of recruitment and the levels of vitamin D in the young recruits' bodies affected whether they fractured, the incidence of fracture or not. So were the spring recruits more likely to fracture, for example, than the autumn recruits, when we've had a summer with, even in the UK, hopefully a bit of sun like today. So I mean, that's very basic, and yes, there was an awful lot of things that we had to consider, like, for example, a lot of recruits went on foreign holidays with their parents before they joined the services, even if they were in the spring cohort. So we had to consider exposure to sunlight rather than season. But that's sort of one end of the study of the kinds of studies. Others, and this one I've highlighted in particular to sort of, again, highlight some of the challenges of working with these kinds of data and then relating it. Physical employment standards, so the tests that make sure that somebody is able to do their job if they're in the emergency services, or the armed services. One of the challenges is, what tasks are you going to give them to do? So it's working out whether you can, if you like, we start with basic difference tests. What sort of differences in timings, what systematic differences do we get in timings if we have a gym or lab-based test to simulate a field event within the job? Are there systematic time differences? How can we get at that information, and then how can we make those adjustments? Is one level of the work, followed by when we do the analysis, you have to be mindful that these are physical employment standards, and therefore we can model it how we like. But rather, like I was saying about the performance analysts, what you've got to end up is with something that you can give the people who test the physical employment standards on the ground with the people who are doing the job. How do they know whether a person passes or fails, or meets the standard or doesn't meet the standard, is good enough in the right sort of areas? So we have to, the analysis moves through from, we actually used an ordinary lease products regression analysis for a lot of this, because of the variability that could happen in the explanatory variables as well as in the response variables. We produced all sorts of models, including some variables and excluding some variables, to see whether what difference they made to the model, in order for us to get the simplest model we could, from which we could produce the physical employment standards that gave people a threshold level, that above that level was competent for the job, and below that level perhaps wasn't. And so that's this particular paper here, if you're interested in that kind of thing, was looking at specialist paramedic roles within the National Ambulance Resilience Unit. The people that go to the resilience unit are called out to sort of more disasters, rather than large scale disasters, rather than your normal paramedic ambulance service. Something else that has come out of Chichester, and I wanted to mention this week because I think it's sort of timely, given that Clem Burke passed away at the beginning of the week. Chichester was one of the founding partners, or three partners, of the Clem Burke Drumming Project, which initially set out a long time ago because one of the founder members was a fan of a fan of Blondie and was interested to know about the demands. Professor Marcus Smith is a physiologist at Chichester, and he was interested in the physiological demands of drumming. And he paired up. The three of them sort of paired up to make a study of the physiological demands of playing during a one-off to begin with, and then multiple gigs in terms of drumming. Now, hopefully this will work. This is the kind of thing that they were analysing with this is the kind of thing that was being analysed. Can you see that, David? Can you come up if that's okay? That was what they were interested in, and what they did. I'm just going to play that once more so we can just appreciate it. Plemberg did that kind of performance whilst attached to a heart rate monitor, a mask on his face collecting expired gases, inhaled and expired gases, and also a brain scan sort of helmety thing in order to look at his brain synapses and things. He did several studies on that with increasing complexity over time. The key finding, unsurprisingly, were that drummers have similar levels of physical exertion as professional athletes, which may in itself sound fairly obvious, or maybe why would we want to research that? But that has progressed to exploratory research back in 2017-18 within a school. It was a very, very small sample. There was only about 18 children because it was a starting point within one school. Matched pairs of pupils with emotional and behavioural difficulties. They were matched with children who didn't have those, were perceived by their teachers as not having those difficulties. They were given 5 weeks of drumming lessons with a professional drummer, and we took a non-parametric and descriptive approach to analysing the data, and we also collected some qualitative data both from the teachers and the children themselves. And one of the key findings from the research was that it was a hyperactivity and an attention deficit was reduced in the children who had emotional and behavioural difficulties by a greater extent than it was reduced in the control group. So there were early indications, while some parts of the studies showed no differences whatsoever. There was a key change in attention and in hyperactivity that was greater in the children with emotional and behavioural difficulties. And from that, further research projects are still ongoing, exploring physical and mental benefits, with a continued collaboration between 4 universities in the UK and Northern Ireland, and I think one's in Germany, exploring possible benefits of drumming in dementia, stroke, and brain trauma, as well as continuing work with autistic spectrum conditions. So what started off as sports science research was transferred to, well, I wonder if this physical activity, how that relates to a physical musician, and what can we learn from this in terms of moving forward. So that's where I want to stop, but hopefully I've given you a sort of, and it is very much from my perspective, a view of how sports science research has started from a fairly embryonic, limited set of skills, to considering wider areas while also knowing the limitations or learning more about the limitations of those areas, and then spawning research into other areas as well. So thank you. I hope you found some of this interesting.